So while we wait for me to get set up, I do normally like to start talks with a humor check, just so people can walk out straight away, as opposed to having to suffer through me for half an hour. So the joke I picked, which is truly awful, is what's the best way to get rid of a headache? You put your head through a window and the pain disappears. Right, people want to, yeah? That was your last chance to leave, right? So people who've seen me before understand what they're getting into. I don't know why you're still here. Those who are new, you'll understand very quickly. It's all fine. All right, come on. Yeah. See if it'll get me or not. It's a new camera. It will. It's fun to play with. Anyway. It's for YouTube. YouTube, actually. Yeah, it's got me enough. That'll do. All right. Make it a little bit higher. All right. Yeah, all right, I'll go back to start. Don't be scared by the number of slides. I talk fast. All right. And I'll just do time. Yeah, all right, cool, works. Okay, so yeah, as was already alluded to, this is how to become AWS's public enemy #1 in a week. So this is the story of, and I'll get into the specifics as we go, but the client I had back when I was working in London, where we were able to find $500,000 of unnecessary spend in 5 days. We'll talk to how it was that there was $500,000 to save and kind of what we did to get there. So there's 3 keys to what we did. The first is design sprints and just the power of focus and actually telling everyone to leave you alone for a week and getting on with things. The second is the power of micro-tooling, which I'll get into a little bit of a definition of what I mean by that. And the last is how to convert micro-tools and all these things and design sprints into systems that you can rely on over the long term. So how do you go from sprint to running an endurance race? Already had a little bit of an intro given. I'm Josh. I'm the modern engineering practice lead for Asia Pacific and Japan for Cognizant. I was, as already been mentioned, I was Perth's first golden jacket receiver quite a while ago now, and I've very much grown out of it thanks to kids. So, you know, they don't last forever. Kids or the jacket? Both. I've done a lot of stuff on AWS over the years. I wrote a book that is on cloud native security that's 1/3 AWS. I have to talk other clouds sometimes. I talk a lot. I like to run my mouth. I've done mainframes. I've done machine learning. I've done a lot of serverless stuff. And yeah, kind of, I run a practice of about almost 100 people around Australia, mostly. Now, looking at how we can help clients with modern engineering stuff. So, show of hands, and you will get escorted out with me afterwards if you say yes, but who thinks cloud is expensive? Yeah, all right. Cloud, in my experience, in my estimation, it's a double-edged sword. So, realistically, good decisions pay off better and faster. Bad decisions hurt quicker and faster as well, right? So, one of my constant refrains is the worst time to start a cloud journey is when your data center exit is due, because it forces you down. It's when they all start because there's a big bill on the table. You go, oh, I don't want to spend that. But actually trying to start with a data center exit gives you a lot of problems about how you're actually doing that. You're then going, well, now I need to move a whole bunch of VMs, and I'm going to do all of that. I have other talks that go into the very specifics of why that's a bad idea and what else you can do in there. But what it generally leads to is cloud estates that are not fit for purpose because of the pending data center exit. You kind of move everything. We all know, or most of us probably know the 7, 8, 9, 13 Rs, whatever they're up to now, in terms of, you know, re-platform, re-architecture. It ends up being lift and shift, data center in the cloud nonsense. Not going to name names. There are places in Perth that have done it. There's places outside of Perth that have done it as well. But where we got to with cloud, and I was actually chatting with my dad on the drive here because weirdly our first graduate roles were both in mainframe. We lived quite a number of decades apart. And back in mainframe time, there was an idea, or still now, because mainframes still do exist, to eldritch horrors of the IT land. But effectively, there was this practice of doing what was called like MIPS optimization and actually looking at the commercial model of mainframes and how you get the best use out of it. Then we went to data centers and stuff started getting slower and pricing kind of stabilized and it stopped becoming a thing. Then cloud came around and we're like, we've got a brand new idea. We're going to start optimizing our cloud, our compute costs and call it a whole new thing. So while FinOps is touted as something new, in my mind, it's existed from the 70s in different guises. And I was fortunate enough to, and the book, you can normally find it, it's one of the O'Reilly ones that gets shared sponsored for free. If what I talk about today is interesting, do go find the book. There are certifications and stuff as well. Those who know me know, yes, I did go get the certifications back when. And I was fortunate enough to actually be taught by the authors because it was kind of early days. Whereas FinOps is this, now it's a whole giant framework of things. But this whole idea of how do you get the best use out of cloud, how do you use it cost effectively, you being efficient and effective together, and there's a whole kind of operating model, culture change, all this kind of stuff in there. From there, and that's kind of where we started on this. And the core thing about FinOps, what everyone says, FinOps is about saving money. It's not. It's about getting to this idea of unit cost economics of cloud. So the idea is, can I tie my cloud spend to my revenue, my profit, all the kind of things I care about? Will doing FinOps well save you money? Yes, but if that's all you're getting into it for, then you've got like another problem there, right? You should be doing something better. So if you can start to tie these things together and thread, we've spent an extra $1 million on cloud, but made $10 million extra from it, why do we care about the million, right? And when you get down to it, effective use of cloud is something that's engineered. It's not managed. And in this story, the problem was they tried to manage it, not engineer it, and that comes with a whole bunch of problems. If people see me talk about security before, one of my common adages are engineers are the source of and solution to all problems. It's the same thing here. The only way to move at the speed of engineering is to apply engineers to a problem. Maybe AI's maybe changing that a little bit. We'll get to AI at the end. So, part one, the energy crisis. So I said this was back when I was in the UK. This was in 2021, and I think it's good to understand the context of how we ended up in the position that we did, the kind of position we were in as being the partner for this client from there. So back in 2021, we were working one of the big 5 energy companies in the UK, and if anyone weirdly is very into the state of the energy sector in the UK, who wasn't living there at the time, and wasn't working with one, the smaller energy companies were all imploding. They'd effectively made this whole bunch of bets on natural gas and all that kind of stuff that hadn't panned out. COVID was a thing, and they all started imploding. The client we actually had was what's known as a supply of last resort, and what that actually meant was, as these smaller companies exploded, you can't take energy off people, you have to move to another provider. That's where you get to supplies of last resort. So they had to actually take on a whole bunch of customers at the rates they were already paying with businesses that had just gone bust. So effectively, they had to take on a whole bunch of customers that were losing money on. And they had to invest a significant amount of capital to actually acquire them in the first place, all this kind of stuff from there. So they were like, oh, wow, our whole commercial model in residential is getting really challenged now. Wasn't, profit margins getting eroded. They had all these customers that were losing the money that they knew were going to churn. So it came to this belt tightening across the board. We'd already been there for a period of time before this. And we were 3, London-based consultant engineers on 3-month contract cycles. We were probably the easiest cost saving to be found in the entire business. We were supported by some offshore engineers based out of India from another provider. So there was this position where we could, it went from, we'll keep renewing to, we don't know, guys. We don't know if we're going to do the next 3 months. We might need to cost cut here. So we went in with a challenge on that and went, well, can we do some shared fake play here? Can we actually let's see if we can actually save you enough money to pay for us to come back for another 3 months. Can we actually engage in that? If we find nothing, sure, we'll try it. If it doesn't work, fair enough, cut us off. But we want to do this with you. We'll commit and we'll turn up properly and do everything we should do. But if we find enough money, you kind of, come on, work with us here to keep us in there, right? So part 2 of the story, ahead of speed. I really like design sprints for far too many things. If people haven't come across them before, they were spun out of Google Ventures. they're pretty much the idea that can you go from idea to learning without having to do the build, the launch, all that kind of stuff. So can you actually get customer feedback from starting with nothing to customer feedback within a 5-day period? And we took this, like the ethos and the idea behind it, and tortured it a little bit to make it work with FinOps. What we ended up with was this FinOps design sprint idea. And to go into another level of detail on design sprints, there's kind of set things every day. You have a challenge, you're trying to generate learning at the end. So on Monday, you pick what you're going after. On Tuesday, you sketch competing solutions, so look at different options of what you could do. Wednesday, you decide. Thursday, you try and turn around a prototype. And Friday, you actually start trying to test with target customers from there. So, stepping through. On Monday, mapping the target. So what we actually had at that time was we actually had multiple different views of the AWS costing. So this was Kudos, which is like an AWS solution pattern that you can grab for free. It works really well. It's like the only thing built on QuickSight I think I've ever actually used, but it does actually work really well. What? I'm being honest. You know what I'm getting here, right? And then the other thing they had was Aptio. This was before the IBM acquisition and all that kind of stuff. So they actually had multiple tools. The client actually had a FinOps team that were there. We're doing things. And I've been talking to like the FinOps lead for a while, and I'm chatting back and forth about what we should do and all that kind of stuff. So it's not that the client thought they were doing this, but obviously we saved $500,000. We found holes as we went along. So from a mapping point of view, even if we go back to here, you can see what your big spenders are from service point of view. You can almost do breakdown by accounts, then look at all that kind of stuff. So when you're trying to look at where your biggest levers are going to be, there's a bit of what's the biggest service, and there's some services that generally have more of an option than others. And I'll get into the ones that were the biggest dials for us as we get there. To spoil it slightly, EC2 was not one of them, and RDS was also not one of them. So it's probably not the ones you'd actually kind of expect, partly because saving plans, reserved instances are a thing. There are other ways to make EC2 hurt less through there as well, and RDS as well. So Tuesday, sketching. So thinking about what we could do. So this was the client's actual third attempt at doing AWS, and they'd ended up with actually 3 AWS organizations, all in differing states. The first one they tried was their data center and exit strategy. It was an unbelievable amount of virtual machines in a really, really small number of accounts. So it was before they understood multi-accounts were good ideas. And they pretty much had these pretty static workloads in there. We'd never touched it before. It'd kind of been off to the side, kind of working along. And where we'd come in, we'd never really touched the thing. The second one was set up by a different provider. In this case, it was the one that provided the offshore resources in here. It'd been ClickOps into oblivion over a number of years. That'll become more important later. It was still mostly static at this point. In terms of the workloads are fairly static, not a huge amount of change. It did host mission critical services to the point of if some of these services went down, the license of the company to trade energy was at risk. So some pretty critical stuff in there. There'd been a mandate of no new workloads in there. And where in this one, we actually had the largest chance of redundant spend in here. So based on kind of the properties of these different environments, there was different options about what to do. So in the second one, in the middle one, we really found there's going to be stuff here we can clean up along the way. And then the third one was the one that we'd been brought in to build at first, infrastructure as code first. Had a large breadth of service consumption. They'd gone on a massive insourcing journey, doing lots of serverless, trying everything in the world, all 200 and something services nowadays. Really dynamic, all new workloads are going here. This is where you're going to have the largest chance of cost spikes, because this is where you've got change. So we kind of had 2 different options here, and where do we want to go after? Do we want to go after the large charge, the big chance of redundant spend, or do we want to go after the chance of cost spikes? Which one's actually going to drive us where we want to go, right? And the cost spikes one, we built it. We intimately knew it. We built everything about it. The second one, we had some experience. We kind of knew our way around, but it was less open to us. And yeah, the first one I talked about, never touched it. So obviously, we're never going to touch the one we've never touched. We're not going to start there. We have no idea what we're walking into. In terms of the bang for buck here, we want to hit the large chance of redundant spend first, because that's where we want to be able to find actual savings, not preventing future spend. That's not really going to get us to where we need to go, right? Then we got to deciding, and this was a bit of a case of like, okay, we're going to go for the middle environment, which I think it was circa 200 accounts, give or take, and mostly VMs, but a whole mixture of stuff around there, some container stuff. And we kind of went to, and then we had to think about, okay, well, how do we actually do this? How do we actually spin up and start to get it to the point where we can understand what's going on, make decisions, and find things? So this was stolen from the Simon Wardley tutor, I forget his surname, talking about model development and microtooling and AI. And there's a blog series turning into a book. If anyone's interested by this whole microtooling concept, let me know and I'll dig out the Medium posts and send them to you. But there's this idea of when we're trying to figure out what we want to do next, there is kind of two top-level bits here. There's the time, how long does it take us to figure out questions, and how long does it take to figure out answers, right? And generally, the thing that slows us down is the fact it takes a long time. We can come up with a million questions, but finding answers is really expensive and hard. It takes us way too long to find the answers, which means we have to pick the right questions that we want to go after before we know the answer, before we can actually understand. So we're kind of shooting in the dark here. And the whole idea of micro-tooling, and this whole concept behind moldable development, if anyone's come across it before as well, is actually trying to pivot that over. So instead of being constrained on your time to answer, can you turn out lots of little tools that allow you to get the answers really, really quickly? So now it's actually, well, I've run out of questions to ask. Can you get into this position, right? So they already had tooling in here. I'd already mentioned Aptio and Kudos and that kind of stuff. They already had these. One of the problems with some of this tooling is they're tools, not platforms. They have change managers, people own them, there's risk around them, all that kind of stuff. So our ability to use Aptio, build on top of it, work with it, and all that kind of stuff is going to be really, really challenged to do. All of a sudden we're going from what can we do by ourselves to now we're actually having to interface with other teams and all that kind of stuff. And it's like, well, we're trying to do something in a week here. If we're having to negotiate access to a platform for 2 weeks, we're never going to get anywhere, right? So we went back at my suggestion to my default I want to do experiments place, which is using Jupyter Notebooks and equivalents, right? So we wanted a quick and rapid way to find answers to questions and build out reusable patterns to enable that from there. Jupyter Notebooks from the Python community, wonderful data analysis tools. They're surprisingly useful in AWS context as well. I use them on an awful lot of things. Generally quite throwaway, but in terms of trying to stand something up, run through Bodo, and get your Python SDK and explore things, they're a really rapid way to just try something out. AI is, yeah, again, maybe changed slightly in terms of how you might attack this. But for us experimentation, there was kind of things we needed to kind of solve for quickly. So then myself and the two other engineers, we could split off and go in our own ways, but we've at least got some patterns to stand on. So the first one was the ability to understand what account exists. So, you know, read in, go, what are all the accounts that are currently active in the organization? So we can start to chunk through and iterate through all of those. And the second is just moving between accounts, making it really easy to just kind of go, oh, I want to run analysis on this account or run this analysis across a bunch of accounts, just building like the rails for scale to be able to do that really, really quickly. So we just set up a couple of Python libraries we could import into the Jupyter Notebook and do to use that, and that became something from there. And then once we had that in place, now we split off service by service and went, okay, well, I'm going to go look at RDS, I'm going to go look at EC2, I'm going to go look at Lambda, I'm going to go look at other things, right? But we had like this baseline in here that allows us to just quickly iterate through what was over 200 accounts, and even the new one we built was about 200 accounts at that point in time. I think it's been a while since I've checked in with the product owner, but it was north of 500, 600 by the time. I think it was just expanding to about 500 because they were doing data center exit into it as I came back to Australia. One little thing, because I do like to talk cyber, if you're trying to do this thing and you want to just quickly use an AWS role for it, use view only, not read only. Please, please, please stop giving people read only. If people aren't aware of the difference between these two, and this is just like a cybersecurity announcement in here, if you take an S3 bucket, if I have view only, all I can see is there's an S3 bucket and I can see properties about the bucket itself. You give me read only, I can start to pull objects out of the bucket. So that's the difference between read only and view only. People generally default to read only. Anyone of the security bent should be like screaming internally, hopefully, about the problems with read only from there. So if you're trying to set this up and you want to, hey, how do I set up the ability to just look at AWS en masse without running into the problems of, well, can I see PI data? What am I doing from here? The view only role that AWS provide you, it's a built-in role, is great for that. Thursday, prototyping. So I'm going to walk through some of the services that we found the biggest savings on from there. So the first one was workspaces. So need to go back in time a little bit here. So COVID was a thing that happened in the rest of the world, but not really here. So I was living in the middle of London at the time, so kind of going through some of the worst of it. So what actually happened in this instance was what we actually did. And there's an AWS case study about this, wonderful. In terms of how could we set up workspaces to have their Citrix farm not fall over in a heap of slag. Because all of a sudden everyone was home for what we thought was maybe a couple of months, turned out to be over a year. So this was a COVID work from home response. So they span up all these workspaces for like every person in the business. And then it had been a year, and we checked, and 80% hadn't been used in 30 days. 90% hadn't been used in the last 90 days. So, there was definitely some bits here where, they'd done the right thing to respond, and then no one had ever bothered to look at it again from there. And, this was circa thousands of workspaces in there. Workspaces, for those that haven't played with them, there's two different versions of workspaces here. There's always on and auto stop. So there's always on where it's always on. Who would have thought? An auto stop where on periods of unuse it turns itself off, right? So what had actually happened here was our friends, the other provider, they deployed an AWS solution that was supposed to go and toggle workspace settings and turn them to auto stop if they hadn't been used in a certain time. So we went, well, everything's on always on. What's actually happened? And it turns out they'd never taken the solution off dry run mode. So it'd just been complaining and going like, hey, you should turn this off, turn this off, turn this off for the longest time. And in actuality, it never actually turned it on and made it actually do anything ever. And that was over 6 months of it just sitting there, just complaining into the wind and no one hearing. What we did around this time as well, and this was something that we actually took to reInvent as well with the Control Tower team, was we built out observability dashboarding for landing zones. There is AWS Marketplace offerings, there's blog posts, there's all manner of stuff around this. It's an open source project that we built at the time, but we actually built using Managed Grafana, Lambda serverless. Again, happy to talk about this in depth, probably offline. But we looked at how do we actually observe a landing zone? How do we know what goes from here? And you can see like down at the bottom, especially with the backup numbers, there's like nothing's in the backup plan. This is because we actually built it into observability before we rolled out the backup solution. So where you do red, green refactor in testing, do it with observability when you're doing infrastructure. You should be able to see your observability complaining that something's not working before you try and make the thing work. So, we were going from that point of like, with the workspace example, it would have been, okay, well, let's actually look at how many are on always on versus auto stop. And let's actually see when we turn the thing on, we actually should see that number moving over time, right? Trust but verify. I came across a thing, I think on Twitter a couple of weeks ago, and it was like, your definition of done should be measured in production, right? I think this still applies to landing zones, it applies to all things, right? So if you're running a cloud platform or whatever, or even an application, right, you should see your observability fail. You do red-green with observability as well as testing. So that's how we build it out. Yeah, there's an open source project if you want to see how we did it and all that kind of stuff. It's all event-based. There's some other bits about it as we go on. This actually turned out to be $120,000 in redundant spend that they were doing in terms of workspace that people weren't using or weren't using enough and all that kind of stuff. These numbers do pile up very, very, very quickly. And these are all annualized numbers. It's not monthly, it's annualized. So it's $120,000 in redundant spend. All right, the next big one that we found, Redshift. Reserved instances. People can probably guess where this is going a little bit. So they'd done the right things. The FinOps team had gone, hey, we're using a lot of Redshift here. We're going to go buy RIs for that. And we'll just go do that. We won't really talk to anyone about it. We'll just go do it and buy RIs and everything will be magical. And then the team redeployed their Redshift off to different instances and we're spending $100,000 a year in on-demand because they'd gone off their RIs. The team had no idea that they'd done this until I went and tapped them on the shoulder and went, hey, you realize you went off your RIs, right? And I'm pretty sure the answer was, what are RIs? I'm like, okay, hold on, let's wind this back slightly, right? So this is, just some of those things that, you do the right thing, you buy reserved instances. If you go through the FinOps stuff, it talks about like, if you're buying an RI for 3 years, but it's saving you 50%, you actually need to project 18 months into the future for it to save you money, right? So there's like, when you're looking at reserved instance, saving plan, all that kind of stuff, don't look at the 3 year, the time, do time minus the percentage saving you're gonna get, because your payoff comes earlier than the entire lifetime of the RI. But also make sure people keep using them. This is why savings plans are good versus reserved instances. They give you more flexibility, all that kind of stuff. There's like RI reselling and all manner of things you can do, right? But this is just one of those things that you do the right thing, but people, especially RIs, happen centrally and the spoke teams have no idea it's happening. So they go and do the right things for them and they're completely unaware of what's going on. The other big one that we had, these are the 3 biggest that we had, database migration service. Again, people can probably guess where this is going. Every single database migration service instance was redundant. None of them had actively done any migration jobs in a period of time. That runs about 6,000 per year per instance for like a a half decent sized instance in here. That are just generally used for a one-off thing. They're used for a migration. There is serverless versions nowadays, so there are other options in there as well. But these things are just like, the FinOps team was looking at EC2 and RDS, and they were just missing huge swaths of other things because Aptio and they have opinions on how you should look at this. Whereas we went in with let's just actually look at what's going on. Let's build contextual tools for this. Everyone's cloud consumption is, there are trends, but it's slightly different. So what works in terms of optimization for one place won't necessarily work at the place next door, right? So then we got to, testing on Friday. We went back to the exec who'd been saying, hey guys, I think you might be done here. Unless we can change something from here. And we went, cool, all right, well, here's $500,000 a year in 5 days you could have saved. So across all of those, and there was other bits around Dynamo, Lambda, S3, there's all manner of stuff that we found, right? But those were kind of the big hitters, right? From there, and unsurprisingly, we did get renewed for another 3 months off the back of that, and I'll get to what we did with that 3 months in a second, because I think it's another kind of cool story, but I'll go fairly quickly through it. So at the top, I said, I was going to talk through microtooling and kind of going design sprints, microtooling, then getting into systems, right? So part 3 of the story is shifting to endurance here. So there is consultants, love them or hate them, probably mostly hate them, but we do have something of a potentially unique advantage in the world that we are fundamentally ephemeral when we go into somewhere. We're always on the idea that we're going to be gone. So really when we're looking at these things, we need to build things that last beyond the engagement, beyond the time we're going to be there, and all that kind of stuff. So this was going to, like shifting into endurance. And I just stole this from James Clear, the author of Atomic Habits, in terms of you do not rise to the level of your goals, you fall to the level of your systems in here. One pattern that I've done to death and probably overdone over the years is taking those Jupyter notebooks I talked about and readily converting them into Lambda functions that you can do. So we kind of, what we did is we took every single Jupyter notebook we had, kind of tore the code out, turned it into Lambda. I think we were using CDK at the time, forget. And then we sent up an event bridge trigger to go every Monday to go, hey, all that analysis we've run, across all the different services, all that contextual stuff running across all accounts. In this case, it was running over the second attempt at AWS and the third attempt at AWS. And we had, okay, we're going to run it every Monday. Product owner gets in every Monday, gets a whole bunch of summaries in Slack going like, hey, there's a potential saving of this on this service, this on this service, this on this service. So at the start of every week, he could go, okay, that number's big enough, we're going to care about it this week, and we'll go kind of tackle it as and when it happens. So there was just that kind of signal coming through that something was getting out of control, then you could go and do it, right? There's no point sending someone off to go and try and solve a $200 saving, but if that $200 saving has got to 5 or 10 grand, then it's probably worth going after, right? One of the other things we did in here, so when you're trying to build this kind of stuff, this is where you're building Lambda functions, and all your Lambda function exists for their entire reason for existence is to talk to AWS. There's a really nice Python library called Placebo that does, if anyone's done like snapshot testing in React and similar things, it does snapshots of your AWS responses and plays them back. Because it's quite hard to go, hey, I want to calculate this number, but the resources constantly change underneath me all the time, so how am I supposed to figure out whether my logic is correct or not? Because I don't know what the answer actually is. So if you're interested in building cloud platform, Placebo and similar tooling that allows you to just capture a response, replay those. So you've got a static response coming back from AWS that allows you to check that all your logic is firing, and then every so often just kind of replay placebo and go fix your tests to re-get the numbers and all that kind of stuff. This gives you the ability to do local development, do all your testing and all that kind of stuff, and run that without having to try and either use local stack, which people know I really don't like, or and yeah, that's another talk again. Or going in and having that ability where your testing is really poor and porous, and it doesn't actually check that anything's actually correct. So often in FinOps we talk about the idea of you have centralized team that focuses on the rate that you pay, and the spoke teams focus on the usage from there. One of the things we started to roll out at the client was the open source tool InfraCost. HashiCorp does this natively with Terraform Enterprise and all that stuff as well. But you can actually put on your PRs the idea of what's the infrastructure I'm running up, what's the actual number that infrastructure is going to run up from there. So you can actually start to get it so people are aware of what they're doing before they do it, because most people don't spend a good chunk of their life looking at AWS pricing calculators. I'm not one of those, I have to, but most people don't have to, so they operate in like kind of ignorance bliss from that, or it's like, oh, we've already deployed the thing and now we've got to try and optimize it, is a different thing, right? So often engineers will optimize anything that they can see. But oftentimes the billing of the AWS account is not something that's given to engineers to optimize, and then we complain when they spend a lot. I mean, it's like, but they can't see it, right? So this is just one of the ways of starting to run up, giving them that visibility on PR before the infrastructure even created in terms of what the cost there is. I believe with Sentinel on Terraform, you can actually do that if the cost is over a certain threshold, then you actually have to get an extra approval, or there's extra logic being built on top of these things. So anyone can run up $100, but no one can run up like 2,000 without some extra level of oversight from there as well. The other things are just, making it so, the AWS Cloud Bill is something that's reviewed by the team on a regular basis, and they're given space and time to work on it. It's not that hard a lot of the time. Okay, so, but that sounds great, right? But I said, going back, that the second environment was ClickOps into oblivion. There was no IAC, or what had just drifted beyond belief and wasn't actually usable anymore. You couldn't actually use the IAC. You were forced in ClickOps because the IAC was just horrifically out of date. Every CloudFormation template was CloudFormation in that one, was just like 3 years old, hadn't been updated, and nothing was right anymore. I quite like the Michael Feathers quote about legacy code, like working with legacy code, a book from, I want to say 80s, early 90s maybe, about legacy code is code that tests. It would then follow that legacy infrastructure is infrastructure that's not managed by IAC, right? If you've got all this infrastructure that people are I didn't define ClickOps. ClickOps is clicking through the console for operations, right? It goes with it, but sometimes people haven't heard it before. So I said we got renewed for 3 months after that. What we actually did with that is we did a ridiculous Terraform reclamation project. So we actually took that middle environment that was ClickOps into oblivion, and we actually managed to, I think across 200 accounts, we got it from 0 IAC to about 40 to 45% with some variance across accounts and that kind of stuff. But we actually went through and pulled it all back in and actually started looking at how can we actually pull this back into IAC with Terraformer and Python wrappers over it and all manner of stuff from there. And we actually had, using the same patterns again, we actually had Slack messages. I didn't have one for the cost. I didn't have a screenshot for the costing. But for the Terraform stuff, we actually had AWS accounts. You could see for every account, in terms of the IAC coverage, how many resources are covered by IAC, not covered, how many are in IAC but not in the cloud provider, and how many have been changed. So we actually had that telemetry on every single account. In this case, it was north of 400 accounts, with the ability to understand of what the IAC health was on any single account. And we had alerting that would happen if the percentage coverage dropped on an account, then there was an alert that went to the product owner, not so we could go hit people, but so we could have a conversation about what happened, what support do they need, how can we help them from there. I designed this and built this, but I'd come back to Australia so other people actually delivered it. With that same client, we took the same design sprint and we actually did a sustainability variant. Being an energy company, net zero, all that kind of stuff, they're very interested in this. And fundamentally, looking at sustainability metrics and CO2 and all that kind of stuff, it's a better heuristic for our using Cloudwell than cost. So cost, you can, like I've already mentioned savings plans, RIs, you can do all these things to reduce cost without improving your architecture. the only way to improve your improve your sustainability score is to improve your architecture. You have to actually make the things happen. You can't pay AWS to hide the CO2 numbers for you. Maybe not yet. I don't know, reInvent's coming up soon. Maybe there'll be something, I don't know. But for now, that's not a thing, right? I said right at the top that FinOps is about unit cost of economics. And I say it's not about saving. And then all I've done is talk for half an hour about saving money. And I just want to kind of get into why we just focused on saving in this instance. And this is, again, a random Twitter quote that I lost who said it, but there's only cost centers brag about cost savings. And fundamentally, the executive we're working with owned a cost center. They were the enterprise centralized IT function. And if anyone's worked at an energy company, their favorite 3 words are cost to serve. All they want to do is lower the cost to serve energy because energy is a commodity. You don't get better energy from someone else, you get the same thing. You want it cheap. And for him, all he cared about was lowering his price, lowering the costs and that kind of stuff. He wasn't cared about, what new innovative products have we enabled, because it wasn't his remit, right? And the problem with FinOps a lot of the time is the operating model of the client doesn't always support FinOps in that bit. So a lot of companies around town, they really struggle to actually be able to draw that thread between where's my cloud spend gone and what's my top line revenue number, or how's that impacting my business in a real way. So there's kind of this, FinOps is not completely reliant, but is heavily amplified by having like a product operating model in place at that point in time. But at the same time, don't let perfection get in the way of progress. Getting these runs on the board starts momentum and starts helping position to that, position over to doing FinOps properly and all that kind of stuff and the benefits you can get from it. You don't have to wait for how can I get unit cost of economics, despite what JR and the others in the field will kind of say the whole point is, and what I said at the top, right? But don't let perfection get in the way. Sometimes you just got to actually go take the wins you can get and see what you can do from there, right? So just to top off, so design sprints are a really impactful way of just trying to turn something around. It's amazing what happens if you decline all meetings for a week. The amount you can get done is phenomenal, right? This was me and 2 other engineers and a product owner, just kind of, we'd spent the entire week doing this, rejected all other calls, and the impact was there to be seen, right? If we tried to do this in around kind of normal day to day, we wouldn't really have got anywhere. The second is the power of micro tooling, and this is where some of the AI stuff gets in here, right? We were writing all this Python Jupyter notebooks by hand. Now I use agents to turn around little tools to just see if I can understand what's going on very quickly and just validate that there's a good signal here. Like if I have a look at this, it may not be perfect, but I can see this avenue is still worth going down, right? Like one of the main thing around, everyone talks about AI in terms of speed. The main thing about AI is actually optionality. It's about you're able to explore more avenues in parallel rather than actually just, I can go faster down the path I was already going to go down anyway. Again, another talk. And the last was building systems in here. So when you're doing all this stuff and the amount of times I've done something with a client and they're like, that was amazing. And then the day job comes back the next day and it was like we were never there to begin with, right? Looking at how you can build these little systems and build these systems so they're just ingrained in the process to become part of the bureaucracy. People hate that word, but it is what it is. And just build those in so they're just always there. The signals are being amplified and shown and all that kind of stuff allows you to turn these things into enduring. As far as I know, those Lambda functions and everything we wrote in 2021 are still running today. As of last time I checked, which was a while ago, they were still running. The product owner was still very thankful of like the fact he was able to do all this kind of stuff, and they became something that, yeah, just for that client, they're just there for forevermore, right? I imagine they probably had to do something because Python versions on Lambda, but anyway, they could have just upgraded them. Now I think about it, I think AWS will have tried to kill them because AWS complained about my Python 3.9 Lambdas that I've had sitting around for a few years on random things. But anyway, that was kind of it. So happy to take any questions. Yeah.
Thank you for the talk. What about change management? Did it slow you down or?
It depends on the service, right? So the workspaces, we just turned them all. we gave people notice of like, hey, we're going to turn it off in the next week unless you do that right, because it's a should be a non-critical service. Some people had abused them, and then were like, oh, no, 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 if you like, you know, that the joke about like, you can't take the laptop out from under the conference table in the main office, otherwise the entire company falls over. Some people have tried to do some workspaces like that, but on the vast majority, we were able to kind of turn those off. The data migration services, again, it was kind of like, hey, we're going to turn this off. That's part of the reason for kind of not focusing on EC2 so much, because that you start getting into operational concerns from there, in which case you lose some of your autonomy. You have to go and do that. From memory, the RI one around Redshift, the team just refused to move it back. The saving wasn't realized because the team just refused. But it's like, okay, well, you can own that 100 grand then, whatever. Like you can't win them all. But generally, yeah, a lot of it was by focusing on the services that are like incidentals around the edge. You can normally do things, or going for non-prod and all that kind of stuff, or just getting into coaching with teams as well and kind of going, hey, look, you can do these things, and that kind of stuff. Sometimes, unfortunately, you do have to talk to other people. It sucks, but you know, it is what it is.
Thanks.
No worries. Any other questions? Yeah.
So the dashboard you are sharing, is it custom built or you are using it?
That was custom. The other Grafana dashboard I showed was custom. Yeah, these are custom. They're open source. Alas, the infrastructure one, Snick bought the open source tool that was using at the core and killed it. So that one's dead. Oh yeah, Kudos. Yeah. Kudos is an AWS solution that you can just go and grab and just deploy on an. I think you can even deploy outside of the org master account nowadays as well, and that kind of stuff. You can do all that kind of stuff as well. The only paid thing I showed was Aptio. This one. That's the only thing you'd have to pay for to get there. And honestly, like, work your way up to it. I think with Kudos and building custom stuff, I think you'll get a lot further.
Is it built on Grafana?
So the ones I did, yeah, they were all AWS managed Grafana. We were back at the time. We were a AWS managed Grafana launch partner based off this work as well. Plus, we went to reInvent with this, with Control Tower team, and a whole variety of stuff. It's slightly more fun part of my work where I just got to mess around in AWS and work with the AWS teams in the UK about this kind of stuff. This was all managed Grafana, and then under the hood, it's Grafana looking at AWS TimeStream, and then using EventBridge and Lambda and Dynamo for event storage underneath that. Again, there's an open source project that I can share as well. It's called that one's called Flight Controller. If you search Contino Flight Controller, because that was the pre-integration company I worked for, you should be able to still find that alive. The repos there and that kind of stuff. Any others? Yeah.
What is your approach for balancing cloud cost optimization with innovation velocity? How do you decide when the conflicts?
I think, like, to a degree, that, like, as I kind of alluded to, there's kind of like a diminishing returns on the cloud cost optimization. So as you build, like, it's worth doing it. If you've been in cloud for more than a couple of years, it's always worth doing cloud cost optimization because things all got out of control. There'll be things to optimize, right? But that's where I kind of got to where we built the systems was we had these recurring signals of, is there a cost optimization problem or like something to go after that's worthwhile? And if there isn't, we're not going to even bother trying to look at it, right? So it's how do you, to take the like Slack example that I had, which was this one around infrastructure compliance. So where we had these Slack messages coming every Monday morning that would kind of go, for workspaces, there's $3,000 that can maybe be saved. For DynamoDB, there's $100. For Redshift, there's $100,000 because someone is not using their RIs again or something like that, right? So what we built was, and this is just kind of platform engineering running platforms, right? We built these signals in place for, is there a worthwhile problem to go after cost optimization wise? Like we built all this in a week. Like you can kind of get started really quick with AI. You can probably do it in 3 days, right? To get this stuff started up, and you can just build all these signals in place to go, I think there is something worth to go after. Otherwise, just forget about it and go, like, we're going to go work on the next feature for the platform from there. So yeah, we just, like the product owner made the trade-off calls like every single Monday as to whether to prioritize that. We were using Kanban, not Scrum, which helps as well in that space, but that's how we did it, by just amplifying the signals out and going, do we think there's something worthwhile going after? If not, we won't bother. So the trade-off was just made every single Monday as we went through. But we had a very good idea that when we started, there was a hell of a lot we could have done. And then we kind of did all of that and then went, it's probably not worthwhile building out more. We want to get back to, we felt we'd gone after the redundant spend, so now we want to go is get in front of the cost spikes, which is where we went back to, we want infra cost, and therefore we need IAC, therefore we need to reclaim IAC. So that became kind of the narrative jumps that we did. And then we got to this point of like, I've never seen anyone try this kind of IAC reclamation at this scale before. Whether that means we came up with something innovative or everyone else knew it was a bad idea, I don't know. But it did work in this guise, right? And then we could get infra cost and other things in place to the point where now we're controlling that sprawl. So now again, we can focus more on innovation and building up more parts of the platform because we put more systems in place to try and nudge people on the right ways from there as well.